All right, good morning. Welcome back, everyone. My name is Steve Mustard. I'm with the International Society of Automation, the program direction partner for IoT Solutions World Congress in Barcelona Cybersecurity Congress. Very pleased to be here today to help MC the events in the auditorium. Great start from Rahul to introduce the conference today, and we're going to keep that discussion moving forward. Our first speaker today is Joost Demarest. He's the CTO of KNX Association, and he's going to tell us about how KNX is constantly on the move. Joost, over to you.
Thanks. Good morning, ladies and gentlemen. When my presentation shows, yes, on screen, perfect. A good morning from myself. Welcome to my session on KNX. My name is Joost Demarest. As said, I'm the CTO at KNX. I will do a short survey. Who knows KNX? Okay. Some of you don't. So part of my presentation will still be interesting for those who do not know KNX. You may know that KNX has been around for quite a while, and in my presentation I would like to deal with the following topics. First of all, we are launching, or we have launched, a KNX IoT tech. So what is this extension about? So I will go back 30 years in time and tell you about the history of KNX, and I will try to explain the title of my presentation. The title of my presentation is KNX Constantly on the Move. I will try to demonstrate you that a technology that has seen the light 30 years ago does not have to be old. It can still reinvent itself, which KNX has done and will do again with KNX IoT tech. I will also explain you, of course, what KNX IoT, this extension, is all about. We have two extensions. One extension is the communication of KNX messages across IPv6 networks. And the second extension is the so-called KNX IoT third-party server. I will also explain you what this is all about. And I will, because of the title of my presentation, KNX Constantly on the Move, we will not stop at that. We will still extend KNX beyond that. And what is so special about KNX, although we have a track record of more than 30 years, and we continue yet another 30 years or more, we try to keep backward compatible, because nobody's very fond of installing a technology and ripping it out 10 years or even shorter. Surely not in a building. Of course, a smartphone you can exchange very rapidly every 5 years, but you typically don't do that with technology you insert into buildings. So I will explain you what we have in store for the next years. And I will round off with a topic, of course, there are now more strict rules against greenwashing. KNX has been about sustainability since day one of KNX. So long before this planet talked about sustainability, KNX put a very big emphasis on sustainability. I will share a couple of words about that as well. So let's go back more than 30 years in time. More than 30 years in time, a couple of manufacturers in Germany said we need to revolutionize the way installation technical and electrical installations are done in Europe and worldwide. So, amongst others, Siemens, but also a couple of other manufacturers, they sat together and they developed the twisted pair technology. The twisted pair technology is a technology that is still used up to today. I would say about 85% of all the KNX products still use this technology. Why is it used so frequently? Because it's a very robust communication technology, and it can cover distances of up to 1 kilometer. Even with the newest technologies on this planet, such distances in a network is still very difficult. The technology from the day one, it's a technology that doesn't have megabit transmission rates, but it was in the very beginning, the inventors of the technology thought we must split up the communication into so-called lines and areas, so that we can have traffic in the installation where the traffic is needed. So not in areas and lines where there is no receiver to this message. The technology was designed by, it was entirely designed by the very first KNX members. And only some providers of chips are there that implement this TP technology. So it's a proprietary twisted pair technology. I've looked in the specifications. I was astonished myself, but the technology was extended already in 2004, so already 20 years ago, with a wireless transmission possibility. So instead of using this green cable, first, the manufacturers designed a single channel wireless solution. So 1868 megahertz band frequency was selected for a single channel communication. In the meanwhile, we have extended this technology with multiple channels. So if a channel is blocked, then the sender can choose another channel that is free. The first solution was a plug, touch, and play solution. So the products could be linked to each other via plug, touch, and play. But we also extended the possibility to integrate these products with our common configuration tool. So KNX is known also for its common design and configuration tool. There's one tool that is used to configure all the products that are labeled with the KNX trademark. In the meanwhile, this technology also caters for low power devices, so even with batteries. And this radio frequency technology can be used with off-the-shelf chips. So you don't have to make a dedicated chip for that. You can use chips that are out there in the market. But the protocol is the same as twisted pair, and it's also completely designed by KNX and its members. The third extension to the KNX technology, also I looked it up this morning, was also started in 2004, so it's also 20 years old. That was the first time KNX made the link between its wireless or wired system and the internet or intranet. So it hooked up its technology to IPv4 at that time. So what we did is, we didn't make it too difficult. We actually wrapped up the protocol into an IPv4 frame. The functionality from the protocol is exactly the same as twisted pair and radio frequency, but of course now other transmission technologies could be used to transport KNX. For instance, Ethernet cabling or Wi-Fi chips could be used to transport KNX. Why was this technology also invented? Because we wanted to also realize a fast backbone in KNX networks. KNX networks of twisted pair, for instance, they have a low transmission rate, but these different islands, it would be good that we could link them up with a fast IP backbone. And also we wanted an alternative to being able to hook up a PC to the network, so via the LAN instead of via USB interfaces. In the very beginning of KNX, cybersecurity, the word had not yet been invented. So in the early days of KNX, people thought, okay, if the cable is buried in the walls, this is cyber secure enough. So fair enough. In the 90s, they didn't think of that, but in the 2000, and we started, I think, in 2008, we thought we might better extend our technology with a possibility to authenticate messages and to secure messages. So what does authenticate mean? Authenticate means that if a sensor transmits a message to a receiver, the receiver must be able to verify that the message really comes from this particular sender. And if you don't have the security keys, it should be impossible to decode the message that is being sent, the data that is being sent. So we designed two extensions, one for the wireless and wired system, and one also for the IP system. So, of course, we did not invent the wheel. There are plenty of security algorithms out there. We chose AES 128, but we designed a security concept around the chosen security algorithms. On IP, we wrap the whole message again in a secure wrapper. So if you don't have the keys, so if you're a hacker and you want to access a twisted pair network or an IP network, you simply can't make out the messages if you don't have the security keys that are attributed to the products by means of the common configuration tool ETS. So, we've now seen 30 years of history, and the manufacturers still said KNX is not feature complete. Why? Because you may have already noticed we didn't have, a couple of years ago, we didn't have the possibility to transport a KNX message across an IPv6 network. And to have really IoT, so to realize a KNX thing even with IPv6. When we started designing this extension, the manufacturer said, we are not going to reinvent the wheel. We want a quick time to market. We're not going to make another tunneled IPv6 approach. They said the Internet Engineering Task Force have come up with a lot of nice protocols. So why don't we use these protocols and just add the cherry on the cake on top and just add that little bit of KNX on top. So the KNX member said, we are going to use the constraint application protocol from the Internet Engineering Task Force, Why? Because the software is out there already. So the only thing that needs to be done is adjust it a little bit to the KNX world. And we also thought there are, for IPv6, there are even more transmission networks that we can use. Not only Wi-Fi, not only Ethernet, or single pair Ethernet for that matter, but there is also Thread. And the big advantage of Thread is it's a 2.4 gigahertz solution, so it is not a regional solution, because our 868 megahertz solution, so the sub-giga solution, can only be used in Europe. So this makes this possibility much more attractive to manufacturers that are marketing their products worldwide. And for the first time, we also decided, our executive board decided, look, if people want to use this technology, we need to provide them not only with specifications, not only a description of the new protocol, but also an open source stack, so that they have a quicker time to market. And we designed an open source stack that can be run on Windows and Linux platforms. So it does need to be adapted to your particular hardware that you want to use, but at least you don't have to design the thing from scratch, from just paper. You also have code. And we see this technology as a big door opener for applications that were previously never designed with KNX. Why? If you have a washing machine, or even if you have a heat pump, or other appliances, typically the manufacturers will not say, this twisted pair technology seems like an interesting technology to be integrated into my washing machine. Because these devices typically don't want yet another type of network connection. So that's why KNX was not an option for that. But Thread could be an option. Single pair Ethernet could be an option. Ethernet can be an option. So we believe this technology will enable manufacturers to step into KNX and make their products part of this entire ecosystem. KNX IoT Point API, as we call it, so the IPv6 communication is now also supported in ETS 6, and we are certifying the first products as we speak. Okay, I promised you there would be a second extension to KNX. The second extension to KNX is, okay, you have this lovely KNX system with wired, wireless products, IP products. Okay, they produce a lot of data, so interesting would be for services to tap into that data. No problem. This is possible since many, many years via the so-called KNX Net IP technology, or even via a USB interface. But the disadvantage of this approach is that the interfaces are quite stupid, actually. So what they provide you is actually this message, this telegram that is being transported across your USB or your IP interface. So you still have to understand this KNX protocol. And it's even worse. If you get this message, and if you understand this to be KNX, then at the end of the message is the data. And this data does not say what this is. What kind of function is this? Is this a light? Is this a temperature? Is this a blind going up or down? You simply don't know. You can't make that out. And you don't know from which room this message comes. Does it come from the kitchen, the bathroom? You simply don't know. There are solutions to solve that. So you can, for instance, export the ETS project and re-import that into your visualization software. But this format changes from time to time when we change our software. And the installer must configure the KNX installation, and he must redo the whole thing if he wants to visualize the KNX installation. So it's a doable approach, but it's not an efficient approach. So why don't we make an approach where we make these interfaces intelligent? So make them into a web server instead of just an interface transporting the data. And why don't we add a export format to our ETS that is not so fluctuating with the different versions? And why don't we add semantics to our data? Why don't we provide the interface with, this is a light, this is a temperature, this is a blind going up and down, and it is in this particular room. So we want to avoid double work of the installer. And if the interface, the web server, is connected to the cloud, then anything in the cloud can connect to that cloud. So the information is shared and it's understandable, and it's not KNX specific. If you want more information on that, there is an open website, knx.schema.org. It's in the last line of the slide. So we will see probably a gradual move from the old stupid interfaces towards more intelligent interfaces using this third-party interface that we have designed. Okay, we've seen twisted pair, we've seen radio frequency 868 megahertz, we've seen KNXNet IP on IPv4, we've seen IPv6 point API, we've seen third-party API interface, so to hook up to the non-KNX world. Will we leave it at that? Of course not. Of course, this planet is full of challenges. One of the upcoming challenges for everyone in this room and everybody making products with a digital element, this will be the EU Cyber Resilience Act. So the EU will impose requirements even for CE marking as regards cyber security. So KNX is prepared with KNX Secure, and it's prepared with KNX IoT, because also for KNX IoT we have opted not to reinvent the wheel, but take security mechanisms that are designed and are documented in RFCs from the Internet Engineering Task Force. But one thing our manufacturers are still doing, manufacturer-specific, is doing firmware update. So if they found a bug in their application, or they found a bug in the system software, okay, you need a specific tool from this manufacturer to pump the data into that device. So this is not very typical to KNX, because KNX tries to be manufacturer independent and tries to support as many features as possible in this common tool. So not in manufacturer-specific tools, but in this ETS software. So we are currently working on a standardized firmware update that will be supported in the ETS. So a first version will be supported towards the end of the year. This is still a unicast firmware update, meaning you will have to update the devices one by one in the installation. We will also design from that a multicast firmware update, so that with one go you can update all the products from from a particular manufacturer for that particular product type, of course. Another thing that you need with KNX Secure is if you want to set up the device, you need a so-called factory default setup key. So you need a key to be able to bootstrap the product. And with this FDSK is used to encrypt the message by means of which the so-called tool key is attributed to the device. But our current ETS allows you to scan these QR codes, which are typically stuck on the product. If you've got an installation of 20,000 products, this is not a nice job to do. So that's why we need a secure approach, so that a cloud infrastructure releases the keys if its product ownership has been proven by the installer. So we are working on an FDSK approach via the cloud. One of the some people tell me, well, if you make presentations, of course, KNX is #1, the best, etc. And no, KNX still has disadvantages, and that's also what keeps us on the move. One of the disadvantages is that KNX and its tool as regards the way products are linked to each other has not changed very much since I work for KNX for more than 30 years, since I began at KNX. So what the installer still does is he gets a product description from one product and a product description from another product, and he needs to link the functions, the corresponding functions, via a so-called group address. So it's still very much function per function, and this is labor intensive. We want to come to an approach where a product typically has channels. So if you have a 4-fold push button, you have 4 channels. If you have a light actuator with 4 lighting channels, you have 4 channels. We actually want to come to an approach where the installer can link a channel to a channel, not a function to a function. So to really lower the effort of minimizing the labor intensity of the job. We call that smart linking. Smart linking will be released gradually towards the manufacturers, and we hope to launch that in our ETS 7. ETS 6 is now on the market. In the ETS 7 we want to launch that approach. Another thing that is a disadvantage in KNX, a disadvantage in KNX is that, okay, you have this tool, you link all the products of these different manufacturers to a working home or a working building. Okay, fine. You leave the building, you take the project on your laptop, or the installer takes the project on his laptop and goes home. And some of the building owners, they simply don't know that they need this project. And then 20 years down the line, I have an own installation at home, of course. Yesterday I had to replace a 30-year-old actuator, lighting actuator, 30 years old. Think of that as sustainability, ladies and gentlemen. 30 years it worked. Electronics that last 30 years, I think you have to look far for that. So I have the project, of course, but if a customer does not have the project, then he's stuck because the intelligence is in the products. But if he needs to replace the product by another product because it's defective, then he needs this project. So that's why we are working on a project server where the projects will be uploaded to the cloud and also shared with the customers instead of giving it on a USB stick or on a CD-ROM. Do you still know about these things? Okay, I will round off with, okay, what is KNX and what is its relation to sustainability and the new thing or the new kid on the block, the energy management. So I've copied a page from Wikipedia and I read out what Wikipedia says about energy management. Energy management includes planning and operation of energy production and energy consumption. And the objective is resource conservation, climate protection, and cost savings. Yeah. We all know that energy management is a hot topic on the world's agenda. And I can say that since the day one, KNX has had a huge focus on energy efficiency. So why have the light in a room when nobody's there? Why have the heating on when the window is open? Do I know what I'm consuming in that particular area? KNX has had a huge focus on that. Why? Why? Because it's a building automation system. And with building automation, you produce data, and with this data, you know what you're consuming, and then you can take actions. With a conventional installation, you can't do that. So control of heating production has been done since many years. Control of air conditioning or heat pumps, it's part of the portfolio of our members. Individual room control. So what my wife likes the best about KNX is that the bathroom is heated in the morning. So because the room individually is heated, and it's not the entire house. Every room can be individually controlled by a room thermostat. It's since the 90s, it's part of the portfolio of our members. Metering and sub-metering, possible since day one. Load management modules, since even the 90s. Connection to the digital meter, also possible with KNX. And you can even monitor your consumption up to the level of a circuit now. So some products allow you to measure the consumption on a particular channel of the product. And you can connect KNX also to charging stations and also to energy storage devices like this Sonnen battery that I have here on the slide. So KNX is the spider in the web. Boiler control, heat pumps, airco, smart metering, e-car, solar, battery storage, peak shaving, sub-metering, all is covered already today with KNX. And how is this typically done? This is typically done, so the energy management application is mostly tailor-made. It's either at device level. I mentioned to you these products that allow you to meter on the level of a circuit, or in a visualization software, or in a central panel you have in your living room, or in a separate home or building server. I have put a couple of them in the slides. And of course, all of that can be managed, it can be visualized, and it can be managed or controlled via different apps from different manufacturers. And who ties all of that together? It's, of course, the skilled KNX partner. We are also working on a concept where it would also be possible to link a energy manager to different KNX energy management things, like a heat pump, like a battery storage, without the help of the configuration tool. So currently we are already discussing this possibility with our members. This was in a nutshell the whole track record of KNX, technology-wise, up to the level of IoT, and also the track record of KNX from day one with a clear focus on energy management and energy efficiency. Thank you very much. If you have any questions, I would be glad to answer them.
Hello. Hello. Any questions? Yes. Just say your name and where you're from. And
Ivan Kravchenko, Germany.
Hello.
Hello. I have a question in terms of application scenarios. Is KNX mostly used for smart home or also extensively for big businesses?
Yes. So KNX has a history, I would say, more in the commercial area. So in bigger type of buildings, offices, hotels, etc. But it also has a good track record in high-end residential, I would call them, medium and high-end residential, where because of the possibility to integrate different applications really at the very low level.
Just one more question. If consider Modbus and BACnet, how do these concepts relate?
Yes.
And in which context do I use these protocols and shop for that devices, and in which KNX?
Yes. BACnet would be typically a, so if you would have a building, or BACnet is typically a building automation system. If you would have in a building KNX and BACnet, KNX would be more located at room level, so the room control, and BACnet would be higher up in the building, so heat production, cool production, etc. would be more handled by BACnet. KNX would be more at the room level. And Modbus, to give you an answer on Modbus, Modbus is a not so strictly specified protocol. So there are a lot of Modbus solutions out there, but mostly they result in a manufacturer-specific solution. KNX has a focus on trying to make it manufacturer independent so that products of different manufacturers can be integrated. Of course, there is a possibility with KNX to Modbus gateway to also integrate Modbus things into a KNX installation. That's possible. And same for BACnet.
What about MQTT?
I'll let you repeat the question.
Yeah. Hello, good morning. I'm Javier Martin from St. Paul. We are based here in Spain. What about MQTT?
Yes. MQTT is, I would say, also a protocol that is used a little bit higher up. So if you would, for instance, have the concept of a third-party IoT web server, which I explained to you a minute ago. So there, it is of course possible if you talk to a cloud that you would use MQTT towards the cloud. KNX concentrates especially on the integration at field level, I would say, of the devices, and integrating that towards the third-party IoT server, but towards the cloud, of course, you could also use MQTT, of course, yes.
Sorry, you mentioned, yes. You mentioned 1 kilometer for twisted pair
Yes, correct.
and radio frequency.
Yeah, radio frequency is we chose, or the manufacturers chose, originally 868 megahertz because they wanted a sub-giga solution, because the lower the frequency, the higher the range. That's why in a typical KNX installation with wireless 868 megahertz, you typically don't need a repeater. So you can typically reach all the products. In a bigger size installation, you would need also repeaters. So we are talking about free range that is about 50 meters or so. But of course, due to obstacles in the room, this may not be possible.
Hello.
Hello.
Great presentation. I'm Panagiotis from Greece. I have based 2 questions on project server for the cloud. The first one is how you are handling the GDPR for the customers, because you are store all the data to the cloud. And the second one is if you are planning to do analytics on this data because you have it. Thank you.
Yes. As KNX, we have a good track record as regards data protection, so we want to keep it. Of course, storing the data in the cloud is, of course, and sharing it with anybody else needs approval of the building owner. That is evident. And your second question was related to? Yes, of course. Of course, analytics on that data is for KNX not possible. Of course not. We have analytics in ETS. So, what functions do people use in the ETS software? So we have different functions in the ETS. So we do have a possibility to do analytics on how is our tool used, and do we provide functions that nobody uses. There we do analytics. There is a possibility to deactivate that as well. So if a user says, I don't want KNX looking over my shoulder, that is possible. But analytics on the use of our tool, that we do. But apart from that, we don't do any analytics on any projects. Yes, of course, if a building owner allows to indeed via the project server tap into that data, of course you can tap into that data, of course. Yeah.
Thank you, sir. It's an outstanding presentation.
Thank you.
I learned a lot. And just question for you, since you work in heavy industries, I have a question about physical mining industry, remote areas. Do you see a possibility of KNX working with IoT database, synchronous or asynchronous mode? The reason I'm asking is that physical mining, wherever there's no network whatsoever.
Mm-hmm.
And the ability to collect the data through the sensors for big machines are very important.
Yes. I do have to admit that KNX is in industrial applications not a commonly used protocol. So it's typically indeed in homes and buildings. I'm not excluding that KNX could be used also for such applications, but it needs to be investigated. Of course, what I did not mention is we have a network of 120,000 certified installers. So in any country on this planet, we have a database. You can look for somebody who can install KNX in an installation, like for your purposes. So you could ask this KNX partner, we call them. Mm-hmm. They have attended a standardized course. and via that, in a country, there is a network of possible people. You could ask, okay, could I, for that particular application, could I use KNX? And then they will help you on that.
So KNX doesn't, how do I say this? In your strategy, there is no edge database on the edge device, on the KNX device itself.
There could be one. There could be one, indeed. There could be on the network could have that. That is not excluded. But I would have to see in more detail what your typical needs are and what the typical environment is where you would like to collect data and that then provide that to an edge computer.
Okay, thank you.
Thank you very much for that, Joost. Please give a round of applause. Our next session will be in here at 12:05, and we'll see you again there. Thank you.